Okay, Algebra 2 students, here is a video for example 2 for section 2.7, solving a linear quadratic system using substitution. We're going to use substitution to solve the system. Here's our quadratic, and here's a linear equation. If you recall, using substitution, you want to set one of the equations equal to x or y, and wow, they chose, well, I guess it's already solved for y, so they took this quadratic and stuck it in here in place of y. Keep in mind the minus sign on the outside. Okay, keep in mind that. So you want to distribute the negative sign, which makes these two negative and that positive. And fill out the equation, it equals 3. So then you need to subtract 3 from both sides and combine like terms, the 2x minus the 3x. So here's the quadratic. After you substitute, here's the quadratic. And then they decided to solve by factoring. Maybe you feel more comfortable with the quadratic formula, but they solved it by factoring 3x minus 2 and x plus 1. They didn't show the work because we've learned that in an earlier part of this chapter. Now that they have these two are the factors, they can set each one equal to 0. X plus 1 can equal 0, which gives you -1 for one of the roots. And if 3x minus 2 equals 0, positive 2/3 would be another root. So those are the two values of x that work. We want to solve the system, so it's not just solve for x. I believe we also need the y values. So you take these values and plug them in. Let's see, which one's easier? I guess if you have the x values, you can plug into this one. It wouldn't be too bad because it's already solved for y. Or if you plug into this one, you'd have to subtract and then take the negative. Either way, you can plug it into either equation. When they plug -1 in, they got y was -5, and then when they plug 2/3 in, they got the value of y was -5/5. So these are the 2 points that are the solution to this linear quadratic system. And they solved it by substitution. Let's see what they want us to try. They give 2 for us to try. And decide, you don't have to do the way they did by substituting the quadratic in. You could solve for the linear and put the linear in, but when you do that, that's going to be a little tricky. Maybe I'll do that as an example. Go ahead and click pause, and I'll try that to give you an example of that. All right, so what did I say I was going to do? I think I know what I said. I'm going to try to substitute this in, but I need to solve it for y, so I'm going to add y to both sides, and at the same time subtract 16. And when I do that, I get 2x minus 16. What you might see is why they chose the other way of solving it, by taking the quadratic, since it's already solved for y, and sticking it in. I now have to take this and put it in here for y. So I have 2x minus 16 equals 2x squared minus 6x minus 8. Okay, so I've substituted. I went the other way than the previous example just to show you an example of that. Now I need to subtract 2x from both sides, and if you don't mind, I'm going to add 16 also to both sides, because I need to have this set equal to 0 before I can solve it using the quadratic or grouping or factoring. I'll make that decision after I see what I get for an equation. So on this side I end up with 0, and on this side I have the 2x squared minus 6x minus 2x is minus 8x, and I'm running out of space. -8 plus 16 is 8. The next thing I notice before I decide which way I'm going to solve this, I notice each of the coefficients is divisible by 2, so I'm going to divide this whole side by 2, and I'm going to end up with 0 equals, when I divide this by 2, I end up with just 1x squared. So that's going to be nice. I may try factoring because I like factoring if the coefficient of x squared is 1. Divide this by 2 and I get minus 4x. And divide this by 2 and I get plus 4. So yes, I'm going to solve this by factoring because I know it's going to break down into a 1x and a 1x. And now all I have to do is find, if you recall from earlier in the chapter, I just need to find factors of positive 4 that when you add them together you get negative 4. So I got 1 and 4, but that's not going to get me 4. I have 2 and 2. Yeah, 2 and 2 make 4, but I got to make them come out negative, so I'm going to go with negative 2 and negative 2. Because negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. Now this equals 0. I'm almost done. Can't write an equal sign for some reason. Here we go. Now I need to find what values make these equal to 0. 2 makes this one 0, and 2 makes that one 0, so it turns out 2 is the only answer for x. Okay, now I need to find the y value. So I'm going to plug the 2, and they plugged it into the linear last time. I'm going to plug it into the quadratic. I'm going to plug a 2 in here, and in here, and see what I end up with. To save time, I'm going to do this a little quicker. 2 times 2 squared. 2 squared is 4. 4 times 2 is 8. 8 minus 6 times 2 is 12. Minus another 8. So I have 8 minus 20 is negative 12. Final answer, the only place where these two graphs would cross, the only solution to the system is the point 2, negative 12. Well, I better check this out to see if I messed up, then I'm going to have to reshoot the video. 2, negative 12. All right. Give this one a shot, and then come on back when you're ready to see the answer. I'm not going to do it out to save time. You understand the two different strategies of substituting. If you do it for that one, you should get, for an answer, 2 answers. 1, 2 should work, and negative 2, 10 should work. All right, your teacher should assign some of these problems, 16, 17, or 7. Have a great day.